Here we will study the practical number 4 of digital communication system. The title of practical is Test the performance of sampling circuit for variation in sampling frequency. In this practical, we are use a PAM kit, pulse amplitude modulation kit for natural sampling, and pulse code modulation kit for flat top sampling. In this practical, we have to adjust first modulating signal frequency, and after that we can adjust a sampling frequency. This sampling frequency is adjust with the help of knob, and we can vary this frequency, and according to the variation of sampling frequency we can observe the output of a natural sample signal and flat top sample signal on CRO. Sampling is nothing but the reduction of continuous time signal to a discrete time signal. When we can convert analog signal into digital signal, then first step of conversion is consist of sampling. In that sampling, we can convert continuous time signal into discrete time signal. Sampling theorem states that a continuous time signal can be represented in its sample form and can be recovered back when sampling frequency fs is greater than and is equal to the twice of highest frequency component of massive signal. Means when sampling frequency fs is greater than and is equal to twice of fm, then there is no error occurred in a sampled signal, and we can reconstruct the sample signal at output. Now we will see the 3 steps. In that we can check the effect of different sampling frequency. If sampling frequency is greater than twice of fm, then there is no overlapping of adjacent spectrum occur, so it is called as oversampling. When sampling frequency fs is equal to the twice of fm, then perfect sampling should be occur. And in last, when sampling frequency is less than twice of fm, then adjacent bands will overlap and error occur, so it is called as undersampling. Now we will check the sample circuit diagram. In sample circuit diagram, we have to apply 2 input. First one is the analog input signal, or it is also called as a continuous time input signal or a massive signal, and next one is we connect a sampling signal, that means a high frequency or train of pulses. So we can make connection on this kit. This is the pulse amplitude modulation kit. In that here AF generator generates the modulating signal, and here pulse generator generates the sampling signal. The output of modulator signal is connected from the output terminal of AF generator to the AF input, and output of pulse generator is connected to a output of pulse generator to a pulse input. Here we have to make these 2 connections short, so modulating signal is applied to the circuit, and next one is a sampling signal is applied to the pulse input of circuit. Now we have to observe output here. So here we will connect probe, and here a ground. Now the positive terminal of output is connected to a red probe of CRO, and ground is connected to a black terminal of CRO. After that we can turn on a power supply and also CRO. Now here we will observe the output of a natural sample signal. Now our knob of a sampling frequency is given here. We have to increase sampling frequency and observe the effect of output waveform. So for one step. Now a sampling frequency is very low, means a part of information is lost here. If we increase or vary a sampling frequency, now as compared to a last, now number of samples are increases, so the information loss is reduced. Now sampling frequency is increases to a higher level. Here we get more number of sample as compared to a last reading. If we increase sampling frequency to a high level, then at a point we get continuous sine wave. Here you will observe that you will get a continuous sine wave, means in that you cannot lost any information and all the information can be recovered back. This is the practical of variation of sampling frequency on the output of a natural sample signal we will study.